Welcome to the video on permutations and combinations. So first we'll talk about the difference between permutations and combinations and what they both are. So in a permutation, the order matters. So you're making a selection of three things, for example, and it's different if you pick one first, then two, then three, versus if you pick three, then two, then one. So these would be two different things. They'd be counted twice. So to do a permutation with a calculator, you click Math, then Probability, and then NPR, where N is the total number and R is the number you're choosing. And then you can use the formula to calculate this as well. NPR equals N factorial over N minus R factorial. So in a combination, the order doesn't matter. So if we had 1, 2, 3, it's the same as 3, 2, 1. So using a calculator, you would do Math Probability NCR, and then using a formula, you have N choose R is N factorial over R factorial times N minus R factorial. So the only difference between their formulas is this R factorial in the denominator for our combinations, because that's taking away all the repeats where it's the same numbers but just in a different order. So here we have our first IB practice question. And for this one, the calculator is allowed. So it says, find the number of ways that 12 different books can be given to Braden, Ethan, Toby, and Thomas if Braden gets 2 books, Ethan gets 4 books, Toby gets 1 book, and Thomas gets 5 books. So for this one, we first need to figure out if we're using permutations or combinations. So the order that someone receives a book doesn't matter. It just matters what books they have. So we're going to use a combination because order doesn't matter. So for Braden, we have 12 total books, and he's going to choose 2 books. Then we'll multiply that by the remaining 10 books, where Ethan's going to choose 4 of them. Then we have 6 books remaining, and Toby gets to choose 1. And then we have 5 books, and Thomas will choose 5. So if you multiply all of those things, you can get your answer. You can do that directly with a calculator, or you can also solve it by hand. I'll show you how to solve it by hand. So for our combinations, it's N factorial over R factorial times N minus R factorial. So our N would be 12 factorial over 2 factorial times 12 minus 2 factorial times our second one, which is 10 factorial over 4 factorial times 10 minus 4 factorial times 6 factorial over 1 factorial times 6 minus 1 factorial times 5 factorial over 5 factorial times 5 minus 5 factorial. So this simplifies to 12 factorial over 2 factorial times 10 factorial times 10 factorial over 4 factorial times 6 factorial times 6 factorial over 1 factorial times 5 factorial times 5 factorial over 5 factorial times 0 factorial. So 0 factorial is 1. And then we can simplify our 5 factorial over 5 factorial, that's 1. 6 factorial over 6 factorial is 1. Our 1 factorial is just 1. 10 factorial over 10 factorial is 1. So then we have 12 factorial over 2 factorial times 4 factorial times 5 factorial. So we'll split our 12 factorial to be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 factorial, because that 5 factorial can cancel with the 5 factorial on the bottom. And then 2 factorial is 2 times 1. 4 factorial is 4 times 3 times 2 times 1. And then we'll have our 5 factorial that we're going to cancel. So our 1s don't really matter because we're just multiplying by 1. Then we can simplify this 2 and this 12 becomes 6. The 4 can simplify with the 8 and make it a 2. The 3 can simplify with the 9 and make it a 3. And the 2 can simplify with the 6 and make it a 3. So we get 3 times 11 times 10 times 3 times 2 times 7 times 6. And that'll give us our final answer, which is 83,160. So there's that many ways that the 12 books can be given to the boys. Here we have a second IB practice question, which also has the calculator allowed. So it says a school class has 10 girls and 12 boys. The teacher is choosing 4 students to help her with a project. A, how many possible groups can be created? B, how many groups can be formed with 2 girls and 2 boys? And C, how many groups can be created with at least 1 girl? So for part A, we're going to use a combination because it doesn't matter what order the students are chosen in, because they're all just going to be put into the same group. So we have a total number of students, which is 22. So that's what our N is. And then our R is going to be 4 because the teacher is choosing 4 students. So we have 22 choose 4, which is 22 factorial over 4 factorial times 22 minus 4 factorial. So that's 22 factorial over 4 factorial times 18 factorial, which is 22 times 21 times 20 times 19 times 18 factorial over 4 times 3 times 2 times 1 times 18 factorial. So the 18 factorials can cancel. The 1 is just a 1, so it's not going to do anything to the calculations. We can simplify with these numbers on the bottom. So this 2 and 22 can become an 11 and then a 1 on the bottom. This can become a 7 and then this can become a 5. So we have 11 times 7 times 5 times 19, which is 7,315. You can also get that same answer if you just enter this 22 choose 4 into your calculator. So next we have how many groups can be formed with 2 girls and 2 boys. So to choose 2 girls, you have 10 total and we're choosing 2. And if we want 2 boys, we're going to also multiply that by our 12 total boys where we choose 2. We'll just go ahead and enter that into the calculator. So we'll find that the answer for this one should be 2,970 groups. So that's how many groups can be formed with 2 girls and 2 boys. And this first one was also groups. So finally it says how many groups can be created with at least 1 girl. Groups can have 0 girls, 1 girl, 2 girls, 3 girls, or 4 girls. So to have at least 1 girl, we'd have to look at all of these possible combinations. So if there's 1 girl, you would have 10 choose 1 times 12 choose 3, because then we still have to choose 3 boys. So you'd have 1 girl and 3 boys. Plus the probability of 2 girls, so 10 choose 2, times 2 boys, 12 choose 2, plus the probability of 3 girls, 10 choose 3 times 12 choose 1, plus the probability of 4 girls, 10 choose 4 times 12 choose 0. So you can do that, or you can use what's called the complement. So you could do the total number of groups minus the probability of 0. So that would be 7,315 minus choosing 0 girls. So 10 choose 0, which means we'd choose 4 boys. So either way, you should get the same answer, which comes out to be 6,820 groups. Next, we have the binomial theorem with rational exponents. So that would be if your exponent is negative or a fraction, then you need to do these following steps. So we need our first term in the binomial to be 1, so we'll factor out that first term. So here we have x times 1 plus y over x to the n, and then we'll separate that exponent, so we'll have x to the n times 1 plus y over x to the n. So then what we would do is we go ahead and separate it. So you'll have your first term, your x to the n, times this entire thing here, where you would start with 1, and then you would have n times y over x plus n times n minus 1 over 2 factorial times y over x squared. And the pattern would continue on and on till infinity. You would start with r equals 0, and you would have your r factorial on the bottom. Your y over x is going to be to your r value, and then you would have n times n minus 1, n minus 2, all the way until you get to your n minus your r value minus 1. So for example, if your r value was 8, so if we were looking for the 9th term, because r starts with 0, your r equals 8 term would be n times n minus 1 times n minus 2 times n minus 3, all the way until n minus 7 over 8 factorial times y over x to the 8th. So that's how you would create each of your terms. So here we have our first practice problem with expanding binomials that have an exponent other than a positive integer. We'll start out by writing this with our fractional negative exponent. So this would be 2 times 4 plus x to the negative 1/2. It's negative because it's in the denominator, and it's 1/2 because it's a square root. So that's our denominator of our fraction. So now we need to write this in the form of x to the n times 1 plus y over x to the n. So we're going to factor out a 4 from here. So this is going to be 2 times 4 times 1 plus x over 4 to the negative 1/2. And then we'll separate these. So we get 2 times 4 to the negative 1/2 times 1 plus x over 4 to the negative 1/2. So 4 to the negative 1/2 is going to be 1 over the square root of 4, which is 1/2. So 1/2 times this 2 is just going to become 1. So this actually simplifies to 1 plus x over 4 to the negative 1/2. So now we're going to expand it with this other side of our expression. So we have x to the n. For this one, we don't have any number before it, so we don't need to multiply it by anything. So then we'll have 1 plus n, which n is our exponent, so negative 1/2, times y over x, which is our second term, so x over 4. So then we have plus n, negative 1/2, times n minus 1, negative 1/2 minus 1, over 2 factorial, which is 2 times 1, so it's just 2, times y over x squared, so x over 4 squared, plus n, negative 1/2, n minus 1, n minus 2, over 3 factorial. And 3 factorial is 3 times 2 times 1, so 3 times 2 is 6, times 1 is still 6, times our x over 4 cubed. And if we want to create our x to the 4th term, that would be negative 1/2, negative 1/2 minus 1, negative 1/2 minus 2, negative 1/2 minus 3, over 4 factorial, which is 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24. So this simplifies to 24, and we'd have our x over 4 to the 4th. So now to go ahead and simplify that, we'd have 1 plus negative 1/2 times x over 4 is going to be a negative x over 8. And then we have negative 1/2 Then we have negative 1/2 minus 1. Negative 1/2 minus 1 is going to be negative 3/2. So that's going to be negative 3/2 on all of these ones. So negative 1/2 times negative 3/2 is going to be a positive 3/4 over 2 times x over 4 squared. So that'd be x squared over 16. Then we have plus negative 1/2 times negative 3/2 times, this is going to be negative 5/2. So that will give us 1 times 3 times 5 is 15. Negative times negative times negative is going to be a negative still. And then this is going to be over 2 times 2 times 2, which would be 8. And all of that over 6 times x over 4 cubed, so x cubed over 64. Then we'll do our x to the fourth term. So this is negative 5 halves. This is negative 7 halves. So we have negative, 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 so that's going to become a positive. And then 1 times 3 is 3, times 5 is 15, times 7 is 105. And then we have 2 times 2 times 2 times 2, which is going to be 16. And then all of that over 24 times x to the fourth over 4 to the fourth, which is going to be 256. And then it would be plus dot dot dot, because it's technically going to go on forever. So this is 1 minus x over 8. 3/4 divided by 2 is 3/8. So this would become 3 over 8. And then times x squared over 16 will give us plus 3 over 128 x squared. This negative 15 over 8 divided by 6, we can simplify these. We can divide them both by 3. So then we get negative 5 over 8 times 2, so negative 5 over 16 times x cubed over 64 gives us a negative 5 over 1024 x cubed. And then this x to the fourth term, we'll divide both of these by 3. So we'll get 8 and 35. 16 times 8 is 128. And then our x to the fourth term will become a plus 35 over 32,768 x to the fourth. And then you would add however many terms that the problem asks for, or until it looks like it's approaching a certain number. So this would be the expanded form of the binomial 2 over the square root of 4 plus x. So next we have an IB practice question. It says use the binomial expansion of 1 minus x to the 1/2 to approximate the square root of 2. So we have 1 minus x to the 1/2. So we don't have a value before. We have a 1 here. So this is good. So it's going to equal 1 plus n, which is 1/2, times our negative x plus 1/2 times 1/2 minus 1 over 2 factorial times negative x squared plus 1/2 times 1/2 minus 1 times 1/2 minus 2 over 3 factorial times negative x cubed plus 1/2 times 1/2 minus 1 times 1/2 minus 2 times 1/2 minus 3 over 4 factorial times negative x to the fourth. So we'll do some simplifying. 1/2 minus 1 is going to be negative 1/2. So these will all be negative 1/2. 1/2 minus 2 is negative 3/2. And then 1/2 minus 3 is negative 5/2. Our 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. And 4 factorial is 4 times 3 times 2 times 1, which gives us 24. So this is going to equal 1 minus x over 2. This 2 on the denominator is same as multiplying by 1/2. This will be multiplying by 1/6, multiplying by 1/24. So for this one, we'll have 1/2 times negative 1/2 times 1/2, which would give us plus 1/8, which is negative, times negative x squared, which would just be x squared. Then for this third one, we can simplify. This can become a 2, and this can become a 1. So then we have 1/2 times 1/2 times 1/2 times 1/2. And 2 of them are negative, so it's going to be a positive 1/16. And then negative x cubed is going to be negative x cubed. And then for our x to the fourth term, we can do some simplifying. This will become an 8, and this would become a 1. And that's all the simplifying we can do in the numerator. So we have a half times a half times a half times 5 halves times 1/8, and 3 of those are negative. So it'll be a negative 5 over 108. And then negative x to the fourth is just going to be x to the fourth. So this equals 1 minus x over 2 minus x squared over 8 minus x cubed over 16 minus 5x to the fourth over 108 plus dot dot dot. So we're approximating the square root of 2. So the original, the square root of 1 minus x, we need that to equal the square root of 2. So 1 minus x needs to equal 2. We'll subtract 1 from each side. So we get negative x equals 1. So x has to equal negative 1. So we're going to plug in negative 1 for x. So this equals 1. And then the negative 1 will make this positive. So we have plus 1/2. Negative 1 squared would be positive 1. So we have minus 1/8. Negative 1 cubed is going to be a negative. So this will be positive 1/16. Negative 1 to the fourth is going to be positive. So we have a negative still, 5 over 108 plus dot dot dot. So this equals 1 plus 0.5 minus 1/8, which is 0.125, plus 1/16, which is half of an eighth. So that will be 0.0625 minus 5 over 108. So 108 divided by 5, we'd have to add some zeros here. 108 can't go into 5, it can't go into 50, it can go into 500 4 times. So we have 432, subtract that and get 68. Bring down a 0, and then it can go in 6 times. So that would be 648. 80 minus 48 is 32. Bring down a 0, and then it can go in twice, which would be 216, 104. And then those numbers would keep going on and on. So we'll have plus 0.0462. So 1 plus 0.5 is 1.5 minus 0.125 gives us 0.375. So 0.375 plus 0.0625. This last one was actually a minus 5/108. So we'll add these. So we'll have 5, 7, 3, carry the 1. So we have 0.4375, which we accidentally lost our 1 when we subtracted. So this should be 1 minus that. So it's 1.4375. So 1.4375 minus 0.0462 gives us 1.3913. So our square root of 2 is going to be approximately 1.3913. And if we check that with a calculator, it's actually 1.4142. So we're pretty close to what it actually is. So in summary, for permutations, order matters. You can use your calculator to solve a permutation, or you can use a formula. In combinations, the order does not matter, and you can also use your calculator or the formula to solve the equations. For the binomial theorem with rational exponents, where the exponent is negative or a fraction, you'll use this equation here, which technically goes on forever. Thank you so much for watching this video, and we'll see you next time.